The n's are common terms, but with log 8 and log 52, we don't know exactly what those numbers are without using a calculator. So to actually subtract these, we'll have to write them side by side. 2n log 8 minus 4n log 52 is greater than 3 log 52. If you wanted to, you could get decimals for each of these, multiply them by 4 and 2 respectively, and then solve for n. Without using a calculator, what we can do is factor out the n. That way n gets separated by taking out just the n. 2 log 8 would stay the same. And minus, without the n, 4 log 52 is greater than 3 log 52. And again, by factoring out the n, now there's no more variables in the equation. Last step, this again just represents a number. We can divide by that number. 2 log 8 minus 4 log 52. On both sides. This term would cancel, and we'd have n isolated or by itself. Our final answer, same as above, n is greater than 3 log 52 divided by 2 log 8 minus 4 log 52. If you wanted to also, you could get a decimal for this, and that decimal would be negative 1.0178. Title of the first section today is changing from exponent form to natural logarithm form. In this section, we'll take problems which are in exponential form and switch them to natural logarithm form, which is similar to log form. The difference is natural logarithms will have the variables ln instead of log. And it'll also go from natural logarithm form back to exponent form. One definition or formula we'll use for this section. Ln, which stands for the natural log. We'll have a small e for base e, and then the two variables will have b and c. So this is the natural log of b, base e, is equal to c. And switching this into exponential form, we'll take the base e, will become the base for the exponential form. And similar to the log equation, b and c will switch sides. So c will become the exponent, and we'll have it equal to b. So the natural log of b, base e is equal to c, is the same as e to the exponent of c equals b. First question we'll look at, in exponential form, e to the negative x power equals 5. Again, taking an equation in exponential form, we can rewrite this in natural logarithm form. Anytime we have the variable e, we can switch that to natural logarithm form. which again is ln, stands for natural logarithm. The base e becomes the base on the natural logarithm. And the two other numbers or terms, negative x and 5, are c and b. We'll switch the sides around. So we'll have natural logarithm of 5 base e is equal to negative x. We can rewrite this without the base of e. So we'll have the natural logarithm of 5 equals negative x. Anytime we have the natural logarithm, it's not necessary to write the base of e. Anytime you have a natural logarithm, it always has a base of e. So e to the negative x power equals 5 is the same as the natural log of 5 equals negative x. Second question and last question for the section. We'll have ln, or natural log, of the decimal 5.2 equals x. Again, we can take this equation, which is in natural log form, and switch it into exponential form. To change natural log form into exponential form, we can add the base on here. And again, anytime you have a natural log, the base is always e. Rewriting this using the formula, the base e will become the base for the exponential form. And the next two terms, 5.2 and x, will switch sides. The x will become the exponent, and the term is what it's equal to 5.2. So the natural log of 5.2 equals x is the same as e to the x power equals 5.2. Title of the last section today is Solving Equations with E. In this section, we'll look at solving equations, which include the variable e from the natural logarithm. First equation we'll look at is 3 times e to the x power plus 1 equals 5. Solving this equation, keep in mind the letter e is a constant. So to solve this equation, we want to find what x is. X will be equal to a natural logarithm or equal to a decimal using a calculator. To first get x, or isolate x by itself, the positive 1 or plus 1, we can subtract on both sides. So we have 3 times e to the x power equals 4. And to continue to get x by itself, instead of multiplying by 3 to cancel it out, we can divide by 3. So we'll have e to the x power equals the fraction 4 over 3. To solve from here, we have the x attached to the e as the exponent. We can switch from exponential form to natural logarithm form. Natural logarithm again would be ln. The base e would stay on the natural logarithm, and the exponent and the number it's equal to will switch sides. So we'll have the natural logarithm of 4/3 is equal to x. Rewriting this, we can take the base e off. So we'll have the answer of natural logarithm of 4/3 is equal to x. If you wanted to, you could use a calculator to find the natural logarithm of 4/3. That decimal would be x equals 0.2877. So the answer to the question, natural logarithm of 4/3, or the decimal 0.2877. Second question and last question for the section. The equation is 5 e to the negative x power minus 7 equals 2. Again, solving this, we want to isolate or get x by itself to find out the value of x, which will include a natural logarithm since we have the letter e in the equation. First step to get x by itself, we can add 7 on both sides. So we'll have 5e to the negative x power equals 2 plus 7 would be 9. Dividing both sides by 5, we'll have e to the negative x power equals the fraction 9 over 5. And again, when you have a exponential form, e to the x power, to solve for x, we can switch this to natural logarithm form anytime we have a base e. So the natural logarithm, e would remain the base, and negative x and the fraction 9/5 will switch sides. So we'll have the natural logarithm of 9/5 equals negative x. Last step to solve, we want to solve for positive x instead of negative x. So we can divide both sides by -1. And if we rewrite the question, we'll have x equals, dividing by negative, we can leave the negative outside the natural log. So we'll have x equals negative natural log of the fraction 9/5. And the base e again, we can leave off since natural logs always have the base e. So one possible answer, x equals negative natural log of 9/5. Or if you wanted to, you could use a calculator, finding the natural log of 9/5 and taking the negative of that number. The decimal would be negative 0.5878. So two possible answers, either negative natural log of 9/5 or negative 0.587.